Hey everybody, hope you're all having a great weekend, or had a great weekend, I should say, and a good Monday so far. My weekend was pretty relaxing actually. I got a lot of side projects I've been wanting to work on, some progress on them, so that's always nice. I did brush up a little bit on my Blender skills, and so we'll probably start doing some art pretty soon, I hope. But today I want to work more on pathfinding. Yeah, so let's just get right down to it. Okay, so let me just start the game up and make sure everything's still working. Right, so we created this really large map just to have something conducive to testing the pathfinding. And down here, oh yeah, the Lua exception says cannot access field find all paths because we haven't actually created anything. Or we haven't actually created any value for that function. Alright, so basically, if you weren't here last stream, pathfinding is just a kind of expensive algorithm to try and find the shortest path to any position. And since it's kind of slow, I want to be able to do it in C# because it's quite a bit faster than Lua. And also, it's just something that will be so common that I'm sure any mod would need it, so we might as well provide it by default in the game. And there'll be basically two ways to use it. Either, well, that's actually what we were working on. We were trying to get together the second way, but the first way is we'd want to find all the paths from a position with a specific length. And that's what this find all paths is. That would be the AStar move. And then the move towards, I guess, is what we'll do here. We'll want to make sure that there is some alive monster that's not ourselves that we can move to. So let's do that. So it'll be local valid target. Starts off false. And then for monster in battle state, get monsters do, and then we want to do something like if monster, or we don't have to do a parenthesis, monster does not equal args monster, which so this means if it's not ourself, and monster alive, then we'd have a valid target equals true, and we can break. So then we just return this. Of course, this doesn't have anything really to do with pathfinding, but it's just the first part of it. Let's actually rearrange this a little bit. So this is just a normal move function. I think it'll be better if we put all the functions to deal with one ability together. Okay, and so the AStar move, and this is the one that just finds you can move anywhere within a certain distance. And the move towards will be a path. We'll want the pathfinder to find a position or a path towards one specific monster. Okay, and that's just something else. Okay, so do something like this, something similar, but we for monster in battle state, get monsters, do if monster again does not equal ourself, and the monster is alive, then we'll find a path to it. So actually it'd just be one path, because the coroutine helper will find the shortest path to the specific monster. Technically we could ask to find all the paths at once and then gather them all up at the end. But that'll just, I mean, that will be faster, but that'll also slow down everything, or not slow down everything, make things more complicated. So just for simplicity, we'll just find a path and get it back immediately. Okay, so what would the position first would be our position and then the target position. So find shortest path from our position to monster position. And then again, neighbors cost. Okay, there won't be a terminate, but there'll be a get heuristic. And if you're new to pathfinding, heuristic is just what's called basically a guess for the distance or from the current search position to the target, and that helps the algorithm find the shortest path in a timely manner, I guess. Okay, so we'll have one option, and so I guess we'd have a move indicator on the ending position. But then we'd also want to have some kind of other indicator on each position along the path, I would guess. This will be the easiest way to do that. So let's say for position in path. So we basically want something like, we don't want the starting position because that's just our position, and then the ending position we already took care of. So I think this will be useful enough that we can have a separate little iterator for this. Let's say middle. I guess that's fine. It need to be get middle positions. I guess we'll do it like that since it needs to be a function. And then we'll just create a new indicator. So mid indicator equals option dot add indicator, and the type is let's call it path, because it'll be something slightly different. Okay, we'll make it simple right now. I mean, well, I guess it depends on the way that the coroutine works, but you might want to know the direction for each position and then have like a different arrow along the path. We can add that later. Did I write that down? Yeah, also we want nodes, which are basically positions, to be generic, and so that basically scripts can give any value for the nodes, and the Pathfinder will be able to search between them. And I think that's it here. Okay, and then move towards. So I guess, yeah, we just move. Oh, we wouldn't move towards the end position. Yeah, actually, here the path contains the start and the end, so yeah, it would be get middle positions here as well. Except we would also move towards the end, so. So what would I call it? Because we basically want everything except the beginning position. So let's say get I guess it shouldn't be positions either because, like I said, it could be generic. So let's just say get middle nodes. Okay, and I guess this will, let's call it get progress nodes because it doesn't include the beginning. Okay, and again, this is the ending node, not position. And then, of course, here. Middle nodes. Okay, so yeah, now now we kind of know what functions we'll need the coroutine helper to provide. And so yeah, basically it's just we want to find all paths from position and then also the shortest path from a position to a specific target. Alright, and then one other thing is we have to pass so many arguments. I think it'd be nicer if we could wrap up these functions all into like one group, and then we could just pass a name for a specific group. Like I have that here. And that way also we could like move these functions out of this script file, which would be nice. So let's make a new one. This would actually probably be in the core mod. Okay, so let's just call it a simple pathfinding, because we won't care about direction. Oh, it's not supposed to be a text file. Let's fix that real quick. Open a notepad. Okay. So we'll need get neighbors equals function. So it would, I guess, it would just be the node basically. Hey Chocofix, nice to see ya. Oh yeah, school tomorrow, okay. I'm just working on the pathfinding for the same game as always. How are you doing? Oh, can't sleep. Well, it's not quite time for me to go to bed, but it is starting to get late. So we have get neighbors. What else? Oh, we have to get the movement cost, and then a heuristic, and then here has like a terminate path. Okay, so get cost, and that would be function to from, and then we'll need to get heuristic equals function, then at and target. Again, the heuristic is basically a guess of the cost. But I think one important thing about the heuristic is that in order for the algorithm to work optimally, you have to make sure that this heuristic is always less than or equal to what the actual cost is. So that can sometimes limit its usefulness depending on how difficult or how complicated your pathfinding might be. So we have this terminate path, which is basically, I mean, one way you could do this is we want to find all paths of just a specific cost, and then you could pass a number. I guess we might support that, but another way is that you might want to find all paths leading to a specific tile type or something, and in that case you'd want to pass a function. But I guess if that was the case, it doesn't really need to be part of this function group, so I won't pass it. Yeah, it's just a heuristic is just what they call that guess value in this algorithm. You had basically your best guess of what the movement cost from a position to another would be. And then I guess protein helpers, register, pathfinding. Should we just make a separate like pathfinding thing instead of having everything being coroutine helper? I think having them in this coroutine helper makes it obvious that it's going to need a coroutine to actually return anything. So I do kind of like it like that. Yeah, it'll be more clear, I think, when well, it'll be probably a few streams, but it'll be clear when we actually get the algorithm up and running. Okay, so actually Pathfinder functions. Okay. Simple. Okay, and so since we do this, now if anybody wants to call a pathfinding or make a pathfinding query with these specific functions, they don't have to actually have the function references. They can just pass this simple to the pathfinders, which I think it'll be a little easier to use that way. So how we'll do it, yeah, it'll be the name, then the position, and then here the cost, which was put 10. And then we also want to support a function and hard-coded move cost and find all paths. So that's all we have to do there, and then here when we find the positions, Yeah, so if we find the shortest path, we'll have the type, and then starting and the target position. Okay, so I think that's it. So now I need to decide. We're gonna jump into the C# side of things, and I wonder if I should start with the Lua interface functions, or start with the actual pathfinding algorithm. I guess I should do the algorithm because these Lua interface should be the like the middle between them that get the two systems to work together. Oh, why is it wanting to reload again? Alright, so I guess I'll put it in the Lua. No, I'll make a new namespace for this. So there might be a few scripts that deal with it. Okay, so what should I call this? Sounds good, as good as any name. All right. So the basics of AStar is you have let's just go ahead and program the main loop. Okay, so actually I think how we'll do it is, because we can have multiple pathfinding algorithms running at once, this core will just stay a separate class, and then there'll be some other class that's hooked into all the games that keeps track of each of them. So for this specific pathfinder, I also don't really want this to actually call the Lua scripts either. So we'll have, okay, we need Q. Actually, I just remembered something important about AStars. You need something called a priority queue, which for some reason is not built in to C#, at least in this version. I think that like Lua has this interesting like experimental upgrade to the newer version of C#, and I think it actually includes a priority queue. But last time when I tried to use it, it crashed the editor all the time, so. No, it's actually not there, it's in the player. Yeah, right here. So I don't think it's safe for me to switch, unfortunately. I think I do have a priority queue. that I use in some other projects. Let me try and find that real quick. Totally forgot about this. I should have gotten it before the stream, so I apologize. Okay, so I think I have this that I made myself for another project, so we'll just use it. I might go back and edit it in the future. Stuff. Okay, and the difference between a priority queue and a normal queue is that the priority queue, every item has a specific, I guess, ranking or priority to it, and it will actually sort the items in the queue and then return to you the item with the highest priority. Is that what this actually does? Let's just look. So we have a sorted dictionary. Okay, so that's what I based it off of. C# has this sorted dictionary type class. And then I have like do something with a linked list. Priority type, I guess that would just be a float, and then the item type. So what happens when you add something? I'm trying to read through this code because I don't remember writing it. So first you get a linked list. Oh, okay, so I remember now. The problem is that the sorted dictionary can only hold one item per key, but technically in our priority queue, items can have the same priority, and then we don't really care what item we get. So I think that's why I had to go through this linked list. And I made things complicated on myself using a linked list instead of a normal list to try and speed things up. Because a linked list is very fast at adding and removing items, whereas a normal list might not be. But I know I've used this item or this thing before, and I guess it worked okay. Yeah, so let's see, we get a new item. First we gotta get a list, and then we add the priority. Oh, this is this sort of dictionary. Okay, so yeah, we add a new list to the dictionary if it's not contained there. And then we just add a new node to the linked list, and then a DQ. Okay, yeah, this is kind of hacky, but the only way to get the first item out of the list is to make an iterator and then just get the first pair and then break. Okay, and then we get the list here and the first node in the list, and then we remove the first. Okay, yeah, then we just clear that node and add it back to the cache. Okay, so yeah, it works, I think. But it's a bit more complicated than I would have liked, but that's fine. Okay, so priority here will be... Well, Lua actually returns doubles as its number. So I guess we'll use that. And then the item type is an object because we don't really care what the actual nodes are. So Q, and then do we? I guess we don't have a stack here. and then we'll have something like add node. And double priority. Okay, oh, and another thing we need actually is a dictionary. That is actually a problem. I wonder, you can't really use... Okay, well... So we can't really use a Lua table and a dictionary because if there are two... like... what am I trying to say? Like if we have two tables... like if we had a table that was this list, and then we had another table but we created it separately, I'm pretty sure that the dictionary would think these are two separate tables even though we might want them to be considered the same. That's because I don't think there's a way that I can give these tables a hash value. So I have a couple ways I could do this. I guess the first way is that we don't make the pathfinding completely generic, and we restrict it to certain things like block positions, and then maybe a block position plus a direction. That seems kind of like a shame. Or I find out some way to do it that doesn't have a dictionary. Also, now that I think about it, the sorted dictionary probably has to have a hash value as well. I wonder, let's see. I wonder if in Moonsharp you can specify a hash value for a table. Not sure, not seeing anything. Yeah, unfortunately, it looks like there's not a way that I can have like Lua be able to pass a hash code. Okay, well then I guess yeah, we'll need to just stick to positions. I guess one way that a Lua script could get around it is that we can support just like numbers for indexes, and then for like some special value they could convert that index into a hash code and kind of hack it like that. So yeah, that's fine. So we'll want to, let's see, make nodes support board positions and numbers as nodes. And then we'll probably want to have, let's see, for future board position plus direction, because I'm pretty sure that we'll need that for later, but we don't even have that type of object yet, so that can come in the future. Yeah, so numbers obviously will be fine in dictionary, and then the board positions I think we did give a hash code. I guess I can look it up real quick. Yeah, get hash code. Okay, so yeah, we'll still leave. Well, I guess now we can actually have a type here. But actually using a generic, would that make everything more complicated? I think so. Well, really, they can just all be dynamic objects, can't they? Okay, but anyway. Another thing that we need is a hash set of visited nodes so that we don't go back over the same node. Okay, and the way it works is when you add a node to the queue, you don't necessarily want to add it to the visited list right that second. You want to do it later when you've actually encounter it in the loop. So another thing we'll want here is like max iterations. And this will just because we probably won't want to run it all in one frame. So I less than max iterations. Let's rename this like frame iterations. We'll probably also want like a total maximum iterations, but I'll do that later. So what we do, node equals queue, and then we'll dequeue the first item. That works, right? Yeah, we don't really care about the priority here, I don't think. And so then we would see if visited contains node. Can we do that, or does it get the hash value from the actual thing inside it? Let's look that up. I hope so, because otherwise it's going to be a lot more complicated. Dynamic value, hash code. Hash code, let's look. Okay, so if it's nil, it just is 0, I guess that's fine. Boolean, string function, table. Wait. So if it's a user data, it just returns 999 always. I don't like that. Okay, well this isn't going to work at all, is it? Well, I guess that unfortunately it does make sense, because I think if it didn't, everything would be it'd be really slow. Okay, so let's see, how do I want to do this? I guess I need to make some other like middle object that will contain the hash value for the node. Another way is that Oh, what was I gonna say? I forgot the other way. Oh, I could do it as a generic, but I think that will just be a lot of trouble down the road, because with generics it's hard to deal with each subtype. That might not be too hard. Well, I think keeping the dynamic value around will maybe speed things up. So let's look up add something here. Actually be a structure, but so I guess I'll just call this a hash code. And it could be a structure. Actually, it doesn't need to be public. So we'll have public float or wait, is this int get? I need to also have to be override get hash code, and we'll have value right here. What's wrong with it? Oh, I have class struct. I think it's going to also want equals. So just be return object does not equal null and hash code does not equal object. Get hash code. Oh, that's not true. It has to be object not equal null and let's see. So if let's not do it like that. Hash code other equals. I guess I can use equatable. Probably needed, actually. So this would just be hash code equals other hash code. And you can actually check the dynamic value. Dynamic value equals other dynamic value. We can't do that because it's a structure. So else if object is hash code, return equals code object, and otherwise it's just false. And we should generate a constructor. Anything else? I think we're good. So now, actually, we won't want to do that probably because we won't ever need to make a clone. So yeah, we'll just pass a dynamic value and then we'll form the hash code from the dynamic value. So if dynamic value type is user data, then this hash code equals dynamic value to object get hash code. Otherwise we'll just use the actual dynamic value hash code, which is fine for non-user datas. Yeah, for numbers it's okay. And so this equals, it works with user data, doesn't it? Yeah, if user data script, okay, it actually checks the objects and then it calls the object equals, okay. I didn't expect to have to spend so long with this, but it's a shame that the Moonsharp get hash code is not as useful as I hoped. Okay, but anyway, so now we have that, and this needs to be a hash code. Okay, we don't actually care about the hash code at this point. Well, we do need it because we'll have to add it to this visited. Okay, so if visited does not contain, then we'll actually do something. And for some reason my code coloring has turned off again. Okay, so now we'll get neighbors. And then we'll see if any of the neighbors is the target. Then we add that to the path and end. Okay, and then, but if there's no target, then it's actually a little different. But I guess either way we have to get neighbors, so we might as well deal with that. So we'll have a list, and that would be just a dynamic values, and this is the neighbor list. Come on. So I'm not sure exactly how this will work yet, so we'll just have a parent. We'll just have a function that will just trust. I haven't gotten the parent yet, so dynamic value parent equals node code dot dynamic value. Alright, and then for each parent or neighbor and neighbors, yeah, I am using AStar, mister. Just starting on it though. There's been a lot of trying to think about how all the different use cases for it will fit together. Okay, so here's where we have a little bit of divergence depending on if we're looking for a specific target or not. So let's see. I guess we'll do it this way. Private bool has target. Well, there's actually three modes here. There's either a specific target and then maximum cost, and then like a terminate function. So I'll have an enumeration here. In fact, let's just create a new enumeration type. So, what do I call this? I guess, end type. This is an enumeration, so we'll have, I always like to start with a none. So the easiest one is target, and then max cost. And finally, what was it? Yeah, terminate function.
7, 6, we have a start, 4, 3, 2, 1. We have booster ignition and liftoff.
Alright, so switch. I guess here is where we'd have to change the algorithm based on the ending type. And I'm hoping that they'll all be similar enough that I don't need to create a different class or slightly different variation of this function, because that would be a little bit of a pain. Let's just start with target, because that's, like I said, the simplest. So if neighbor equals, oops, I guess we'll actually need a value for the target. So if neighbor equals target, well, let's see. What would we do after this? I guess we'd end this path. Would we? Yeah, because in this mode we just take the shortest path to the target. But I guess, do we need the cost first? No, not here, because if we find the target, then that's it. We're done. Okay, but that also brings to question, how will we store the paths? Okay, let's create a new class to help with that. And right now I'll just make it a black box, which means I won't actually do or implement anything inside of it. We'll just see what functions we need. Okay, so path storage.
9,000 gigs of RAM, and it can't answer a simple question.
That actually, we probably have to store like all the previous. Let's see. So I'm trying to think. Is there any way that a path could enter a node more than one different ways in such a way that we'd actually care about the second? Actually, no, because it would have already, we wouldn't even get that far because this visited would have been filled. So I was going to say that maybe we need to store the sorry, it's right on the tip of my tongue. Store the entire previous path along with the actual node in these inside the queue. But since there's only ever one path that will lead to a specific node, I don't think, I mean, we obviously don't need to do that. We can do it a little easier. We might not, excuse me, we might not even need the path storage. So let's see, dictionary. Okay, we can't use that, we have to use the hash again. Since this is a dictionary. I guess technically we could use hash code to dynamic values, so might as well. And then yeah, every time we get to a neighbor, we'd insert that into... Oh, well, see, this won't work because because you could have multiple neighbors. Let me see here. I guess what we'd really have to do here is this dictionary would, the key would be like the current position, and then the value would be the previous node. But the problem is we don't know that right away because excuse me, the cost could be different. Or, I mean, because we don't know for sure the shortest parent until we actually pull it out of this queue. Now we don't store the previous node in the queue. So I guess that means I need to. Okay, so let's change this from hash code to I guess queue node. So yeah, I would have what did I just do? Oh yeah, I removed usings. I guess that was fine, but whatever. So I want to rename this to what should I call this? This is the one that like at the head. So I guess we can just call it the head, and then we'll have a previous. Should probably all be private actually, because you shouldn't be able to change them. And then we could just have encapsulations. Oh, we actually don't need that. Okay, and I also need to pass the previous here. Let's rename this. And again, the hash code will be based on the head. Okay. So here we'll also I guess we'd also need to store like the complete cost to this point. This will be how to add a node from the outside, so we have 0 cost, and then we'll have a private void. Yeah, let's rename this add start. So really we'd want the Q node for the previous, or let's just call it parent, and then dynamic value head, and probably double cost. So the Q node also needs to store the cost to this point. So what do we do here? Actually, let's just call add node. The parent is it's actually null, but let's do it this way actually. So the head, null, and 0. So this would be enqueue. Okay, the cost. The cost is actually the same as the priority, isn't it? So cost new queue node parent. Oh wait, wrong way. Head parent cost. Now, should we have this node like already take into account the previous cost? Probably. And if that's the case, we don't really need to pass a queue node to it. Because, yeah, that's fine. Let's change this to total cost just so to be, or even better, path cost. Okay. But I guess all that doesn't really matter at this point. But yeah, so if we get this far, we're going to actually execute this node. So we add it to visited. And then we'd also add that into the paths here. So paths node code equals node code well, actually the node code itself contains the previous, doesn't it? But it contains the previous dynamic value, not necessarily the node. So I guess how I could do it is each of these nodes would actually just contain a reference to the actual queue node before it. Seems fine. I don't, because it's just storage. And if we did that, we wouldn't need to have this path at all. That means we can't pass a null here. How do we handle that? Because this is like circular. Oh, I guess we just can't use the constructor for that. So public static queue node start, and then we'll just return new. Oh, I need to have. So if we do that, then basically it's just okay, you can't even have cycles. Okay, I guess we have to upgrade this to a class then. Which, I mean, doesn't really cause any problems, except we have to worry about garbage collection. Okay, so now we're going to go back to queue node for this. We don't need this path value. Okay, so anyway, at this point, yeah, we're done. So what to... I Guess we'll just have a, I'll just have a function complete. How would this, we need to like force complete, so I guess we can't really, oh well, no, we can clear the queue, can't we? So yeah, we also need to check and queue. Oh, we don't have a count. Oh, we have an empty. That's kind of silly though. Public int count get return dictionary count. Okay, so at this point we would just clear the queue, because if we find the target, we don't care about anything else. But yeah, this, then we need to add okay, so we need to have in order to reconstruct the path, I guess I should have something here. Queue node, target node, and then we can just set this up here. So head, or wait, it'd be neighbor, or actually I can just pass target, can't I? Parent, and then we'll have a get cost, private double get cost, dynamic value 2 from, and I'll just return 0 for now. Actually 1, because if you have a 0 cost, that will cause problems. But and so then it would be, oh, I can't use, I need to use, let's just rename this to node. The node cost, do I not have the cost? I guess I didn't encapsulate it. Plus get cost. Node, previous, head, and target. Oops. So what this does is we just get the cost for from moving from the previous to the target. I guess I could have done it this way. Parent to target. Yeah, I'm actually making things more complicated. Yeah, this should be node head, but I can already just use parent. Okay, so target to parent, and then the cost. The cost. Oh wait, I actually have to use the node because I need to pass the actual queue node. But of course, obviously, the new cost for this new path from this path to the target is the path's cost plus the new cost from the parent to the target. So that's what this does, and then just having reference to target node, I'll be able to reconstruct the path this way. Probably, I should probably actually do it where I have like a list of ending nodes, now that I think about it. Let's go ahead and do that. And then we just add that here. And So down here, if Q count is 0, then we're done. So we can clean up a little bit. Also, I should remember to clear the neighbors here. And then we should have something here. Public pool is complete. And this would be return Q count is 0. Okay, so obviously here we need to keep searching, find costs and heuristics. And then we also will have to handle the other types here. So we'll have max cost and a terminate function. And they'll be slightly the same, I mean, slightly different, I should say. You can probably pull out this code actually and use it for both of these. I'll write everything inline for now. Okay, well I went a couple minutes over, but I think we made some good progress. Started on AStar on the main loop so that we can... We'll kind of work backwards from here because this will be what does all the work. And then we'll have a lot of supporting scripts because we'll need other objects that will... Actually, didn't need this, so I'll go ahead and delete it. But other scripts that will call the different Lua functions that we were provided. And then scripts that will compile the paths into the objects that we actually use here in Lua. And then we'll also need something that will store specific pathfinding things, so we won't have to do this big algorithm every time a script asks for the paths, because like in between ability usable and get targets, nothing has changed, so we really don't need to execute pathfinding twice. And I think we should be good. We just gotta remember to implement all these different uses. But anyway, thanks everybody for watching tonight. I hope you all have a great night. I'll be live tomorrow around 8:30 Eastern. And if you missed some of the streams, feel free to check out my YouTube channel, which you can find a link to in my channel description, or by typing !YouTube in chat. And also, if you want to chat with me or other developers or viewers, you can check out my Discord channel, which you can find the same way by typing !Discord in chat or in my channel description. Alright, well thanks again everybody, and have a great night. Bye-bye.